Hi, this is Lauren Paulson, and today I'm going to describe an experiment we did about oscillating motion. So this experiment had two types of oscillation motion, the oscillation motion of a spring and also a mass swinging back and forth. This experiment involved the physics principles of velocity, force, gravity, potential energy, both spring and gravitational energy, and kinetic energy. And here are the equations we used: the kinetic energy, the potential energy of gravity, potential energy of a spring, the force of gravity, and the force of a spring. So I'm going to go through GlowScript now and show the things I changed. The first thing I changed is the ball's mass to make that the mass of what the weight on the spring actually was. Then I changed the initial position from what I got as my initial position on tracker. The next thing I did was my spring constant, which I calculated, and the length, which I calculated. Then I went through and I set all these equations equal to each other so that the velocity and position and energy changes updated. And then as we run it, we get a position versus time graph that looks like this. Now, how did our predicted motion change compared to our observed motion? Our predicted motion has a much longer period, well, not much longer, but a longer period, and has a different start height and end height. This means that our prediction motion, it predicted that it would take longer for our oscillating motion to complete one period, and it also thought that we would start our motion slightly lower and end slightly lower than it actually did. So predicted is the blue. What we actually did was the red. As you can see, blue is a bit longer, bit longer, bit longer, bit longer, and starts a bit lower, ends a bit lower. So those were our big differences. Now, the next question is the energy principle satisfied in this experiment? Well, when we ran it, like I said, I got it so the energy got outputted and changed over time in the code. So this is our change in energy versus time. And so we have the change in kinetic energy and gravitational energy and spring energy as the green, red, and blue. But our total energy is going to be this orange line, which we can see stays at 0 and is not oscillating with the motion. It stays constantly at 0 the entire time. So since the total energy stays at 0, this means that no energy is being created or destroyed within the system. So the energy principle is going to be satisfied since energy cannot be created or destroyed. And this shows that because there is no new energy and it is not losing energy. So yes, the energy principle is satisfied. Then what were our estimates of oscillation period? Now from tracker, I could do an estimate of an oscillation period by tracking periods, and to get a bit more of an accurate measurement, instead of just doing one period, I would do multiple and divide it by the number of periods. So for X, we just got 4 different periods, and I calculated 4 periods, well, observed 4 periods with 6.458 seconds over 1, 2, 3, 4 periods, which gets us an oscillation period of 1.6145 seconds in the X for the oscillation period. For the Y, we get a slightly smaller period of oscillation. And again, I calculated this in the same way by just doing 1, 2, 3, 4, 5 periods of oscillation, which was 7.407 seconds. When you divide it, you get an average of 1.4814 seconds for the period of the Y. These slightly different periods, so X has a longer predicted oscillation time, and the X direction is going to be the object swinging back and forth with a small impact on the Y because it will swing a bit upwards due to centripetal force. But the Y is mainly going to be the spring. This means it takes a slightly longer time for the object to swing back and forth than spring and bounce up and down. Anyway, hope I was able to describe that experiment to you well and explain the ideas of oscillation and oscillating motion. Thank you.